Today, let's consider the graphs and equations of circles. We will start with the mathematical definition of circle. A circle is the set of all points equidistant from a fixed point. This fixed point is called the center of the circle. The center of the circle is usually denoted as the point with coordinates h, k. The constant distance from each point on the circle to the center of the circle is called the radius of the circle. It is customary to denote the radius of a given circle by the letter r. The standard equation of the circle with radius r and center at the point h, k is given by the equation quantity x minus h squared plus the quantity y minus k squared equals r squared. Although I've already given away the punchline for the equation, let's figure out why this is the equation of a circle. Consider the given circle with radius r and center at the point h, k as shown. We want an equation describing all the points of the form x, y on this circle. From the definition of circle, we know that the distance from the point x, y to the point h, k is r. So the distance formula gets us that r equals the big square root of the quantity x minus h squared plus y minus k squared. Squaring both sides of this equation yields the standard formula for an equation of the circle. Now let's consider three typical examples of problems with circle. First, let's write the equation of the circle with center at the point -2, 1 and radius 3, and then determine whether the point with coordinates -4, 3 is on this circle. For the first part, we can simply substitute hk equals the point -2, 1 and r equals 3 into the equation for a circle. Writing the equation we are going to use both reinforces our memory of it as well as helps eliminate errors when we substitute. Now we plug h equal -2, k equal 1, and r equal 3 into the equation. Then we simplify where appropriate to make the formula neat and clean. For the second part of the problem, we want to know if the point xy given by coordinates -4, 3 satisfies the equation. So we plug in x equal -4 and y equal 3. Simplifying, we get -2 squared plus 2 squared, which equals 4 plus 4, which equals 8, but not 9. Therefore, we conclude that the point -4, 3 is not on the given circle. Let's consider a second, more algebraic example. Find the center and radius of the circle with equation x squared plus y squared plus 8x minus 6y plus 24 equals 0. We are told that the equation is a circle, so we need to rewrite it in standard form. From there, we can identify both the center and the radius. The technique used here is to complete the square. Recall that we complete the square on an expression of the form x squared plus bx or y squared plus by. We begin with the given equation and rearrange the terms on the left-hand side and move the constant to the other side of the equation. Now we have the correct forms to complete the square. We add 16 and 9 to both sides of the equation. Let's now consider a second, more algebraic example. Find the center and the radius of the circle with equation x squared plus y squared plus 8x minus 6y plus 24 equals 0. We are told that the equation is a circle, so we need to rewrite it in standard form. From there, we can identify both the center and the radius. The technique used here is to complete the square. Recall that we complete the square on expressions of the form x squared plus bx or y squared plus by. Starting with the given equation, we rearrange the terms on the left-hand side and move the constant to the other side of the equation. Now we have the correct forms to complete the square. We add 16 and 9 to both sides of the equation. Recall that to complete the square on x squared plus 8, we take 1/2 of 8, which is 4, square it, and add that to both sides of the equation. Similarly, to complete the square on y squared minus 6x, we take 1/2 of the coefficient minus 6, yielding -3, square that, and add that square to both sides of the equation. We now have two perfect square trinomials on the left-hand side of the equation. The first is x plus 4 quantity squared, and the second is y minus 3 quantity squared. Notice that in both cases we have the variable minus b over 2 quantity squared. If we compare our equation to the standard equation for a circle, we can easily identify the center and the radius of our circle. The center is the point with coordinates -4, 3, and the radius is r equal the square root of 1, which is also 1. Now let's consider a final example, like the last one, where the algebra is a little bit messier. We want to find the center and the radius of the circle with equation 4x squared plus 4y squared minus 24x minus 12y plus 27 equals 0. We will use the same technique of completing the square, but first we need leading coefficients to be 1. So starting with our given equation, we see our leading coefficients are 4. We have to divide both sides of the equation by 4 to have our leading coefficients equal to 1. Next, we rearrange as before, putting our x terms together, our y terms together, and moving the constant to the other side of the equation. Now we add both 9 and 9/4 to both sides. When we complete the square on x minus 6x, we take half of -6 to get -3, square that, and add 9 to both sides. But when we complete the square on y squared minus 3x, y squared minus 3y, we take -3/2 squared and add 9/4 to both sides. Now we have two perfect square trinomials on the left-hand side and a constant on the right-hand side. We get x minus 3 quantity squared plus y minus 3/2 quantity squared equals 18/4. We had to get a common denominator on the right-hand side to add. We get -27 plus 36 plus 9 all over 4, which gives us 18/4. Again, we compare our equation to the formula for a circle to identify the center and the radius. Then the center is the point 3, 3/2, and the radius is the square root of 18/4. We take the square root on top and take the square root on bottom. We have that the square root of 18 is the square root of 9 times the square root of 2, which gives us 3 square roots of 2. And on the bottom, the square root of 4 is 2. Therefore, the radius r is 3 square roots of 2 over 2.